Okay, so we are going to check in here with the anatomy of the Earth. So we're going to start with the layers of the Earth. And I wanted to tell you too that if you see this in red right here to help with your Cornell notes, if you see that in red, that means that is a new subject. So in the Cornell notes, that's going to go over on the left-hand side as a new subject. All right, layers of the Earth. So we've got the crust. Again, crust is going to be on the far outside. And the crust includes the lithosphere, which we'll go over in just a couple slides. Then we've got the mantle, which is just below the crust. And it's actually composed of the Lithosphere, which is the upper mantle. So if you imagine that this mantle is actually divided into two pieces, there is the upper crust here, and then the lower crust right there. The Lithosphere is in the upper mantle. So then we've got the lower mantle, which again, right here. Then we've got the core, and the core is divided into two sections. The outer core, right here, and obviously next, the inner core. All right, so the crust. Let's start with the crust. The crust is a thin layer of rock that forms the Earth's outer skin, which includes the oceanic crust, which is the ocean floor. So right around here, here's our ocean floor. I'm going to make this white so you can see it. There's our oceanic crust, right there. This is going to be the thinnest. I wonder why. Then we've got the continental crust. And this is the land. This is going to be thicker. So it is thickest actually underneath the mountains, interestingly enough. So let's see. So if we imagine, like, we've got the continental crust right here, okay? Then the mountains are going to be on top of that. That is going to make it the thickest because obviously it's going to go from here all the way to the top of the mountains. So that's why the continental crust is thickest where the mountains are. All right, so I told you I was going to talk about the Lithosphere, or excuse me, the lithosphere. So here is our lithosphere right here. Now, if you look down here, the lithosphere is the crust and the uppermost solid portion of the mantle. Okay, so it's a rigid layer made of the crust and the uppermost layer. Oh, go back there. All right, and the uppermost layer of the mantle. So this sits on top of the Lithosphere. So right here, this right here, that's the Lithosphere. Lithosphere. Boy, I say that one 5 times fast. All right, so the mantle is a layer of hot, solid material between the crust and the core. So it lies between the crust and the core of the Earth. So again, the Lithosphere is in the upper mantle, and it is a softer, semi-solid piece, semi-solid layer. So it's kind of the consistency of almost like a taffy. So it's not, it's kind of yeah, taffy's pretty good. And it lies underneath the lithosphere, otherwise known as a portion of the crust. So the interesting thing, because it is the consistency of taffy, it can move and flow slowly. So what might that lead to? All right, the lower mantle is actually the solid portion of the mantle. Remember, the mantle is divided into two pieces. P-I-E-C-E-S. It's solid because there's so much pressure pushing down on it. So you've got the entire weight of all of these layers pushing down on the inner core. So that has a lot of downward force. All right, the core is the center of the Earth. And there's an outer core right here. And this is a core of the molten metal that surrounds the core. So right here. And then we've got the inner core, which is going to be right here. And if you take these two together, let me erase this, make it a little clearer. If you take this entire distance right here, it's about the size of our moon. So the inner core right here, let me change the colors here. The inner core right here is a dense ball of solid metal. And the thing is, it is very, very high in iron. So that is what helps give the Earth its magnetic attraction. So thank the iron, thank the core right here, for why compasses work. It plays off this solid inner core of iron. So it is, again, it is solid because of the immense pressure that's on it. There's so much pressure, as a matter of fact, that while this is the inner core, go back there, the inner core right here, it is a liquid, but there is that's the worst ever, but there is so much downward pressure from the entire Earth on it that it actually makes it behave like a solid. So, again, yeah. Do. Pressure, it makes the liquid behave like a solid. So, there is the anatomy of the Earth. Hope you like it. And